Welcome to Week 4 Exploration 2, and welcome to our first official schedule slip. The technology needed for our planned Week 4 isn't quite ready in time, so we've cut some of our plans for Week 5, and we've moved some of our Week 4 plans into Week 5. And now for Week 4, we're going to spend a bit more time with programming with recursive functions. In this video, I'm going to show you how to write a tiny expression language and an evaluator for it. Specifically, we're going to write an expression language for arithmetic on natural numbers with plus, and then we're going to write an expression language for Booleans and logical connectives. And then in this week's exercises, I'm going to get you to extend them with more features. Okay, so to start off with, I've got the data type of natural numbers, and for convenience, I've given names to the first few numbers. And then here's the definition of plus. So now I'm going to say that an expression is either a constant natural number or it's plus of two sub-expressions. So for example, I can make an expression for representing 2 plus 2 by find 2 plus 2 equals plus of constant 2, constant 2. And in fact, I can say test 2 plus 2 and ask will expand the definition for me by turning 2 into SSZ. Okay, so I can write an evaluator for this language, which is a function that inputs an expression and outputs a natural number. So, and we're going to do this recursively on the expression itself. So I'm going to write define evaluate E, inductively E, and then I'm going to write from E. Now, ask will tell me that an expression is either a constant or it's plus of two sub-expressions, and I'll give these slightly better names. Now, in the case that we want to evaluate a constant, we can do that just by returning that number. Now, in the other case, we have two sub-expressions, and what we can do is recursively evaluate these two sub-expressions and then add together the results as natural numbers. So I can say equals evaluate E1 plus evaluate E2. And this plus now is the actual addition function. So you can see what we're doing is we're sort of turning the plus constructor into actual addition of actual numbers. So now I can write test evaluate 2 plus 2, and ask will tell me that it's 4. Okay, so there's a few obvious problems with our expression language. One is that the only operator it supports is plus. So this problem is for you to fix. In this week's exercises, I'm going to get you to add some more operators to it, such as subtraction and multiplication. Another problem is that the syntax for writing expressions is kind of horrible, but that's something that I'm afraid we'll have to live with for now. One more problem is that it doesn't support variables, and I'll deal with that now. So it turns out when you make an expression language like this, it turns out to be a good idea to make the type of variables into a parameter. So I'm going to add a parameter for the type of variables. And then I'm going to say that an expression could be a variable. And I now have to carefully add V everywhere, otherwise I get lots of error messages. Like this and like this. Is this enough? Yes, okay. Now, in order to evaluate an expression now, we're also going to need a thing called an environment, which is a mapping from variables to values. So if we were doing this properly, we would use some kind of lookup table, but then I'd have to think about how to make a lookup table in Ask. So I'm going to fake it by saying that an environment is a function from variables to natural numbers. So here it is, a function from V to N. And I'm going to name this input EMV for environment. And now I also have to carefully add this everywhere. Otherwise, I also get lots of horrible errors. And I've made a mistake. we go. Okay. Okay, now we also, so the new case that we have to deal with is this variable case. So in that case, in the case that our expression is a variable, we need to look up the value of this variable in the environment, which in this case we do by function application because the environment is just a function. So I write env v, and now I'm done. Okay, so to test this, I'm going to have to actually pick a type for variables. So to make my life easy, I'm going to decide that I only have 3 variables called A, B, and C, and I'm going to make a data type for that. So ABC is either A, or B, or C. And now I can set up an environment like this, which is a function from this data type to natural numbers by saying define my env v from v. And now I get to actually pick the values. So I'll say that A is 1 and B is 2 and C is 3. Okay, so now I can, for example, make an expression of A plus B by saying define A plus B is plus of the variable A and the variable B. And now I can say evaluate A plus B, evaluate A plus B in my environment. What have I done wrong? I should say, sorry, test evaluate. Okay, and now ask tells me that for the values of the variables that I picked, A plus B is 3. Okay, so let's delete all of this. And let's also delete all of this. So just the same, I can also set up an expression language for Booleans and logical connectives. So here's my data type of Booleans. And now I can say that a Boolean expression is either a variable, sorry, or it's a constant Boolean, or it's not a sub-expression, or it's and of 2 sub-expressions, and so on. I'm missing out my V's here. And now my evaluate function will take an environment from variables to Booleans and an expression, and it will return a Boolean. I again say inductively E, and then from E. And now similarly, when we have a variable, I can just look it up in the environment like this. When I have a constant, which is a Boolean, I can just return that Boolean. Now for the other cases, I'm going to need actual functions that operate on actual Booleans to do these things. So for example, I can write the not function from bool to bool by saying define not B from B. And then I can say define not true equals false and not false equals true. And now when I have a expression which is not of some sub-expression, I can say recursively evaluate that sub-expression, and then take not of it. Okay, and the AND case is something that I'll get you to do in the exercises. Okay, so hopefully in the next video, we're going to get on to something which is genuinely new for this week.